Okay, so having found the internal forces, we move on and calculate for our displacement. Our displacement delta K would be equivalent to 1 over EA into FP times Fn times the length of the rod. Let me call it L. So this would be equal to 1 over EA, then into beginning with this one here, like this rod here has got an internal force of 0. So the FP is equal to 0, then the corresponding Fn is negative 1. When I multiply the two, I get a 0, so it cancels out. Then when I look at this rod here, the internal force is 0. Then this one here, the internal force is root 2. When you multiply the two, it cancels out with 0. So we are left with this rod, this one, and this one here. So beginning with this one here, our FP would be equal to negative Fp, then times corresponding Fn on this, that is times negative 1, then plus, we must also multiply its what? We must also multiply its length. Length was A times A, then plus, we look at the next one. Let's say this one here, this is negative Fp times the corresponding one has got a negative 1 for the Fn, then the length is also A, and then lastly we have this rod, this one here. So it's Fn is Fp is root 2 Fp, then times the Fn, which is root 2, then times the corresponding length. Its length would be root 2 A, like that. So when you compute this, we come up with our answer as okay. So this would be equivalent to 1 over E A into, this would be giving us a 2. This plus this gives us 2 Fp A, then plus 2 root 2 Fp A, which can also be written in simple as 2 Fp A to Fpa over En, then plus into 1 plus root 2, and that is our displacement at point K. So next we look at the displacement at point C. So for the sake of displacement at point C, we've got to add a unit force at the point C. So point C was this upper hinge, so we add Fp is equal to 1. So if this is Fp is equal to 1, the next part we now find the internal forces on the on the system due to the action of Fp is equal to 1. So first, as it was in the other case, we first look for the members that have got no internal forces. Now we still look at like this rod, like this one and this one here, they are on a straight line. Then this one combined with them, they form a T. So this one here has got internal force which is equal to a 0. Then when this one moves away, this one here forms an L joint. So at the L joint, we said if there is no action of a force, the internal forces would be equal to a 0. So we are only left with two trusses, this one here, and this one here, like that. So since this one here is in horizontal magnitude Fp is equal to 1, that means we must have an opposite one at this hinge, which is also Fp is equal to 1. Then these two here form a what? They form a couple that causes the system to rotate in the anti-clockwise direction. Therefore, the vertical forces also must make up by then that causes the system to rotate in the clockwise to counterbalance it. So this would be upward force. Then this one here would be a downward force, of magnitude 1 and then this also of magnitude 1. So that being known as that, then now we come and like if this is a 1, that means the internal force here would also be equal to a 1. Then at this point here, then for the sake of this slanting one, we shall be having a magnitude of negative root 2, yeah, like that. Then having found our internal forces, we go on and calculate our displacement as delta C would be equal to 1 over EA into so we multiply the forces, then times the forces times the length. So we know that this one here is a 0, so this one here we cancel it out together with this one, which is with this one, and then yeah, even this one here cancels out like that. So we are only having two trusses left, two rods. We have this one and then this one here. So displacement would be equal to 1 over EA into if I begin with this vertical one, I would be having my force FPN as negative FP, then times here I have a 1 times 1, then times length A, then plus the slanting one, I would be having FP as root 2 FP, then times negative root 2, then times its length, which is root 2 A, like that. So when I compute up this, I would come up with my displacement as A is common, so I pull out A. FP is also common. FP divided by EA. This is EA. Then I'll be left with 2 root 2, then minus a 1. That is our displacement at point C. So basically that's how we compute the displacements on truss systems that are statically determinant. Thank you.